Flipped classroom video for Maths A2 Unit 3, differentiating logarithmic functions. So we want to differentiate log x itself. So starting with y equals log x, that means that x is equal to e to the power of y. So we can differentiate that. dx by dy is e to the y, and that means dy by dx is 1 over e to the y. And of course, because e to the y is equal to x, that means using our chain rule dy by dx equals 1 over dx by dy result, we get dy by dx is 1 over x. Having a look at the graphs, the green graph is, as I hope you recognise, log x, and the purple one is 1 over x. And so looking at the log curve, we can see that it starts close to 0 with a very high gradient. It's very steep, but that it gradually gets less and less steep, and as log tends to infinity, the gradient is tending down to 0. What if we have log of another function? So if we have y equals e to another function, you will remember, hopefully, that dy by dx is g dashed of that function times e to the original g of x. And it might be that we get a similarly neat result for y equals log of g of x, seeing as e to the x and log x are inverses, therefore very closely related. So what we can do is use a chain rule approach, so we let u equal g of x, and y is therefore log of u. So dy by du is 1 over u, as we've just seen, and we know that dy by dx is dy by du times du by dx. So that means we have dy by du, which is our 1 over u we've just found. Du by dx is just g dashed of x. And by subbing back in for u equal to g of x, we get 1 over g of x times g dashed of x. And the result that dy by dx is equal to g dashed of x over g of x. And this is very handy. So for example, if we had to differentiate y equals log of x squared plus 7x minus 6, all we have to do is to find dy by dx, we think about what do we get when we differentiate x squared plus 7x minus 6, and that is of course 2x plus 7, so that's our g dashed of x from above. That goes on the top, and then on the bottom goes our original g of x function x squared plus 7x minus 6. So that's quite neat.